So for this talk, where JJ asked me, do not talk about multi-objective optimization, but talk about Swarm Robotics, which is one of my my research fields. And with this talk, I want to basically give you an overview of what I'm doing. So I will give you a motivation on decision making, which we require in Swarm Robotics and robotics in general. Then I want to talk about individual decision-making versus collective decision-making and show you what is now actually currently the hot topic in this area of collective decision-making. And at the end, I want to also raise the topic of ethics in AI and decision-making. If someone is working on decision-making, of course, needs to deal with this topic of about ethics, even if I'm not an expert in that area. So before I show you the collective decision-making, I want to give you an overview on what is decision-making. Well, decision-making, or the so-called multi-criteria decision-making, is not a new topic. It goes back to, well, there is actually a very nice journal paper where they go back to the King Solomon. They talk about decision-making in that sense. But in this talk and in my research, actually, I work on modern multi-criteria decision-making, which is introduced by Pareto. I think most of you know that. And I don't want to really take your time in explaining what is Pareto optimality and all these aspects. But the problem with decision-making is that if we are confronted with a decision-making task, we have to select one of the alternatives. And what does that mean? Mathematically is defined in this way. You have a search space, you can see here. This is the search space of all the alternatives that we have. And for each single alternative in this search space, we can measure a function, a criteria. And if you have more than one criterion, so you have several criteria, like function 1 to m, then you can plot them here in terms of each other, and you have the so-called objective space. And your alternatives from this decision space, this search space, they can be easily mapped to this objective space, and you can identify the ones that are the optimal solutions. We know that if we have multi-objective problems, we do not have one single optimal solution to this problem, but we have a set of optimal solutions. Here it is shown for minimization. And one thing you can see here, a solution here is basically better than all the solutions which are shown by these two lines here, because if we are